Hey everybody, this is Mr. Munson. We're in Unit 4, G4, Triangle Inequalities. As you can see from here, the student learning map shows that we have 4 basic concepts that we're going to try to learn and master before the end of this unit. That means basically 4 videos, and this is going to go pretty quick. So I want you to get ready. We're going to go ahead and get started with our vocabulary words. If you don't have this document, you can go down to the description below the video. There's a link there, and you can download it and print up your own. Let's get started. Okay, as always, you will not write where I'm writing. That's you're going to leave those lines blank. You're going to write behind here so that you can fold this over, cover it up, read through the directions there, or read through the descriptions and the definitions, and see if you can quiz yourself on it. Okay, so if I ask to see this, for a grade or something, and you have something in those spots, I can't give you credit. That's not following the directions I've given you. All right. First thing is, if you go to the last page of the document that I gave you, you'll see something that looks like this. And so on this page, it represents the different shapes that we're going to be looking at when we go through this. Now, as we go through that first page, each one of these shapes goes with one of those definitions. Now I want to challenge you. I want you to look at the definition. I want you to put me on pause in just a minute. Look at the definition. See if you can figure out which picture goes with each one. All right. Put me on pause and see if you can do that. All right. Let's see if you got it right. So the first one is talking about in a triangle, there is a special line that goes from a vertex to a midpoint, okay? Now, a picture that looks like that is a picture that has a median in it. This is called a median. Now, what I want you to know is that each triangle has 3 medians. From each vertex to each side is another median. I'm going to only have that one drawn there just to keep our reference simple. All right, let's go to the next one. The next one is when we're given a triangle, from the vertex is a line that cuts each of the angles to be congruent. This is called an angle bisector. I hope that one is easy enough for you. Now what we know is that each angle has an angle bisector. It cuts the angle into 2 congruent parts. Okay? Now again, I'm going to keep the picture simple. Let's go on to the next one. A blank of a triangle is perpendicular segment. Let's just draw a picture here for a second. Okay. A blank of a triangle is a perpendicular segment from a vertex, okay, to the line containing the side opposite the vertex. So it's a perpendicular. Sides are perpendicular to each other. That comes from a vertex and goes to the opposite angle. And so there's that particular kind of segment we're going to need to know in this unit. This is called an altitude. And once again, each vertex has one of these. So just like all the other shapes or all the other special segments, there is one that comes from this one and goes here, and that's perpendicular, and so on. Each triangle has 3 of these special segments that we've already talked about in each of its triangles. I'm just showing you one of them. Let's go on to the next one. How about a perpendicular bisector? I probably should spell out perpendicular, don't you think? All right, there's that. A perpendicular bisector is basically a segment that bisects a segment, so it's going to go through the midpoint, and is perpendicular to it. Now notice we've had a perpendicular to a segment or to a side already up here. Now that one came from the vertex and didn't bother going through the midpoint. This one doesn't come from a vertex, just bothers hitting the midpoint. Now interesting enough, I wonder what kind of triangle could have them both the same thing. So this is the answer. If this was an equilateral triangle, we would find out later on that that means it's equiangular. All the angles are the same. So what we find out is that the altitude comes from a vertex and is perpendicular, also hits the midpoint. All right, we'll discover that a little bit more detail as we go through this unit. A blank dash blank of a triangle is a segment that joins the midpoints of two sides of the triangle. Let's see if we can draw that. So here's a triangle, and it connects two midpoints. So let's draw a midpoint there. Let's draw a midpoint there. And this segment connects the two midpoints. That's called a mid-segment. Mid-segment. All right, next. All right, the triangle inequality theorem basically says this. The sum of any two sides, so if I add up any two sides, they must be greater than the third side, okay? So, I have three sides in this triangle, and if you don't mind, I'm just going to use some lowercase letters here to represent their lengths. I don't know what the numbers are, but basically what this segment, or what this theorem says is this. If I take side A and side B and add them together, that sum must be bigger than that third side. Now, this makes logical sense if you think about it. If I lived, this was my home and this was my school, and my friend's house was over here. Now, if I was to drive from my house straight line like a bird would fly to the school, it would be some distance. I'm going to call it C here. Then if I drove from my house to my friend's house, and then from my friend's house to the school, man, I gotta tell you, I think we all know that the two lengths driving to my friend's house and school has to be a greater number than the third side. And so what we're going to do is we're going to be able to look at triangles here in this section. Let's make that a 5. Okay, and we're going to ask, is that triangle possible? If I had a board that was 3 feet long, a board that was 1 foot long, and a board that was 5 foot long, could I actually build that triangle? And I would argue no. And the reason is because this side plus this side only equals 4. That is not greater than the third side. All right, we'll discover that in greater detail when we get into the unit. All right, Pythagorean theorem, if a triangle is a right triangle, then the sum of the legs squared is equal to the hypotenuse squared. So let's just write in the Pythagorean theorem here. Now, the Pythagorean theorem converse, okay, let's just stop for a second. Remember, okay, so the Pythagorean theorem basically says that if you have a right triangle, then we find out when we square the two sides that are not on the right angle, that form the right angle, that has to equal the hypotenuse squared, okay? The converse of it is this, a squared plus b squared equals c squared. That if I take the three sides of a triangle and plug it into the Pythagorean theorem and it works, the left side equals the right side, then I can conclude it's a right triangle. But if it doesn't work, then it must not be a right triangle. All right, so let's take a look at that. If this is true, then this is true. That's the conditional statement that we have now for the Pythagorean theorem converse. Well, suppose I take the three sides and I stick it in the Pythagorean theorem and it doesn't equal c squared. Then it must be not a right triangle, which leads it to be either what we're going to call an acute triangle or an obtuse triangle. Now, just for reference sake, we're not going to worry about why this is so, but in our vocabulary sheet here, I want you to fill in the blanks, or in this case, right in the back here, so that you can correct yourself. This is what I call the three bears theorem, and there's absolutely nothing that's true about this being called the three bears theorem. This is a theorem that I came up with. It comes to us just from the idea of what it sounds like. If you remember, the three bears was, there was porridge. There was some porridge that was too hot, too cold, and then there was porridge that was just right. All right, so what we're going to find out is if we plug in the two sides, the two smaller sides of a triangle, and we plug them into the a squared plus b squared, if we find that it's smaller than the c side squared, then we find that it's an obtuse triangle. In other words, c is too small to be a side for a right angle. I mean, too large for it to be a right triangle. All right, and then we'll have an acute, which is that it's too small. And then we'll have it so that it equals, and it's just right. You'll understand that better when we get there and go through it in that unit. All right, well, that's pretty much it for now. Let's go to our Duet problems for this. A couple review questions. You should be able to do these just because we've done these problems before. Now, this is, again, Duet problems. You're going to copy down the information. Write a title here, vocab, Duet problems, right? Don't forget to put your name, date, and block number over on the right-hand side for full credit. I'm going to start taking points off now. We've done this long enough. I've got plenty of people who are putting their name and everything over here. I know it doesn't bother you any to put it over there, or it doesn't matter to you much, but I'm seeing if I can get your brain to start following certain directions, because I believe that those things are going to be important for you to follow logically and reasoning that we're going to do this year. So for credit, full credit, you're going to be putting your name and your date and your block number over there, and I hope that doesn't cause you too many troubles or worries. Don't forget to put your title, and then also make sure you always are writing the original information, this stuff that I have here. Make sure you're circling your answers as well. All right, well, that's it. We'll see you next time.